1. What happens as you approach 0 from the right? 1. Got it? In your notes, it says this right here. So I'm not writing it down because it's all here. From the left, the function value appears to be approaching 1. From the right, it approaches 1. At 0, the function is undefined. Okay, how about this one? What the? By the way, that's the graph of sine of 1 over x. If you were to graph sine of 1 divided by x, that's the graph. Let me zoom in for you so you can see what's going on in here. What's going on? That's a weird function, huh? Maybe Desmos can handle that function. Let me type it in, see what Desmos does. No, Desmos didn't appear to like that anymore, did it? If I zoom in here, what's going on in here? Starting to hallucinate. Weird function, huh? So it's like we're approaching, let's see what's happening at 0. Let me go back to the, no, it's a really weird function. So there's the function, okay? What would happen if I asked you to plug 0 into this? So I'm trying to figure out what's happening at 0. Just try plugging 0 in there. What do you get? 1 divided by 0 is undefined. So we know that this function at 0 is undefined. Okay, how about from the left? And then from the right as we approach 0. So imagine you're over here to the left of 0. Here's 0, right? Imagine you're over here, you're walking on this function, and you're going to go like this, right? Are you headed towards anything? You can't tell me you're headed towards 1, because then you're going to come back down, right? You can't tell me you're going negative 1 because you're going to go back up, and then back down, and then back up, and then back down. And you're doing this oscillation like infinitely many times, aren't you? Like if you don't believe that, right? You saw it in here? These oscillations there's so many of them happening, the computer's almost drawing it like a shaded region because there's so much in there, right? So does it look like you're headed towards one particular value? No, you're just doing this, right? Haven't seen this before, have we? How about from the right? Same situation, right? Coming from the right, we're doing this. This is the first time we've seen this. So we need an answer for this. Basically, we need a way of saying it's not headed towards a number. Right? That's what we need to be able to say. It's not headed towards a particular number. We do not want to say undefined. We use the word undefined when we're talking about a function's value at a point. When we're talking about this idea of a limit from the left and the right, if we get something like this, we use this instead. We write does not exist. Does not exist. Now, another way of writing that is D-N-E. That's not an O, that's a D. D does not exist, all right? We're going to abbreviate it. D-N-E. What does it do from the right? It does not exist. It's all those oscillations which is causing the problem, all right? Any questions, Hector? You all right? Yeah? Anyone else? All right, this one is another one of those situations where the computer is having an issue. Back in college algebra, we would consider this function as having this irrational function as having a vertical asymptote at 0. Ignore this red line. That's the computer freaking out and not knowing what to do at 0. So this graph really looks like this. It goes like this and down like that. And then this goes up like that and like that. All right, first question. In unison, what's the value of this function at 0? Undefined, right? Undefined, because at 0, right? Look at the function. Can't plug in 0 into that, right? You get division by 0. Okay, so at 0, it's undefined. What is happening as we come in from the left? To 0, right? Here's 0. Come in from the left, you're walking along this function. Where's the function headed? Down forever, right? Which is negative infinity. Right? This we haven't seen. So the value of the function at 0 is undefined. From the left, it's headed to negative infinity. And from the right, where's it headed from the right? If you come into, here's 0, coming from the right, where's it going? Where are you going? Positive infinity. Do y'all have questions on that? Everyone see it? That it's in negative infinity, positive infinity? How about this one? What's the value of the function at 0? Undefined, right? Plug in 0 into that, it's undefined. What happens as you approach 0 from the left? Infinity. From the right? Infinity. Is this all making sense? All right, so this is basically, in words, me telling you everything that I've just told you right now. The idea of the limit, we're trying to figure out what's happening near some value, x is 2 or x is 0 or x is a, right? We do not care what's happening at x equals a. We inspect the behavior of the function, right, as we approach that value from the left or the right. When we do that, one of three things can happen. Either the function can be approaching a number, like in the very first example, we approached 8. The function could oscillate infinitely many times, which was that sine function, right? That weird one. Or the function could approach positive infinity or negative infinity. Those are the only possibilities of what can happen when you talk about a limit from the left and the right, or the right. It's either going to head to a number, it's going to oscillate, or it's going to take off to infinity or negative infinity. Those are the only things that can happen. Now we need some notation for this, right? Like for me to tell you, hey, look at this function from the left or from the right. We need a better notation, don't we? So now we have some new notation. And this is the first time for many of you that you're actually seeing this. Let's say you're given a function. I'm going to write this on the side over here. So you're given some function f of x, right? You're given some function f of x. Then if we write this, LIM, that stands for limit, and then it's usually right below it, x with an arrow to a with a little negative sign in the top right corner of the a. Not the negative in front of a, top right, superscript, up to the right. This right here, if I write that, that's the notation right here. That means, hey, tell me what's happening as you approach a from the left. That's just the mathematical symbols that we will use to ask that same question that I've been asking you this whole time, right? To come in from the left. Why do you think we use a negative sign for the left? The negatives are over here, right? Positives are over here. So just coming in from this side. What do you think changes if I want you to come in from the right? Change that little negative to a positive. See? That's called the right-hand limit. The other one was called the left-hand limit. See it? All that changes, that little plus sign. So this is your right-hand limit. This is your left-hand limit. This is your right-hand limit. It's your left, and this is your right. We good? Do those answers have to be the same? If you are looking at a function and you come in from the left and from the right, do those answers have to be the same? Did we see any examples where they were different? We did, right? We saw examples where they were different. These don't have to be the same, right? These don't have to give you the same answer. They can be different. I think, what would be a good example of that one? We had that one right there, right? The left-hand limit was 8. The right-hand limit was 4. They don't have to be the same. They can be the same, right? Like, there, that one right there, right? As we come in from the left, it's the same as coming from the right. So they could be the same. They don't have to. Hold on, I'm losing myself here. Okay, so I just gave you the right-hand limit, right? Now, very important point. When we want to evaluate a limit and look at approaching x from both sides, then what we're going to do is we're going to use the following notation. So if I put a minus, it means look from only the left, right? If I put a plus, it means look only from the right. The way I'm going to tell you to look from both sides at the same time is to not use a plus or minus. If I take this minus out or plus out, that means you have to inspect it from both sides. You would think you would put like a notation where you'd put the minus and the plus together, right? You just put a minus and a plus and that would tell you check from both sides. That's not the case. The way we do our notation is that if we just write this down right here, that means, where does it say it here? Well, it means you're coming in from both sides. So let me go back to this right here. All right. This is a good one to look at, and this will hopefully clarify everything. So let's look at this one. If I write this, limit x approaches 2 with a little negative sign of this function. Stephen? Where's Stephen? Stephen? All right. What do you got here? What is this? What does this mean? Approach 2 from the left. What would you get? 8, as far as you can tell, yeah? Everyone agree? Okay, good. Stephen, you want to keep going? How about this one? Now I want you to come in from the right.
Approach 2 from the right, so undefined.
Well, undefined here, but you are approaching a value, right? You're approaching 4, right? You're approaching 4. So this would be 4, yes? So now this question. What is the limit as x approaches 2 if I don't put a plus or minus here of this function, right? I want to know what this is. So I'm asking without giving you any sort of guidance here. Jacob? Okay, Jacob, any guess as to what the answer to that would be? This is asking you to come in from the left, right, Jacob? This is saying come in from the right. You're clear on those? Yeah. Okay, this one's asking you to actually come in from both sides and tell me if you have an answer. What do you think our answer should be for this? Somewhere in the middle, okay, right? It's like, wait a minute, hold on, right? Jacob's saying, hold on, these aren't the same answer, right? If they were both 8, then would it make sense that this is 8? Or if these were both 4, would it make sense that this is 4? But they're different, right? What this is telling you is to look from both sides and only give me the answer if they go to the same place. If they go to a different place, you are going to put this. D and E does not exist. All right, Jacob, that makes sense to you? Because these don't match, right? In order for you to put a number here, these two have to be the same answer. So this is like, you're only checking from one side here, you're only checking from the other side here. Here you're checking from both sides, and you need them to both be going together for it to work. Let's look at another example. There. Look at that one. Look at this graph here. What's the limit from the left as we approach 2? What's the limit from the left? 8. What's the limit from the right? 8. So that would be, I'm going to leave this up here. From the left of 2, it's 8. Now this changes, right, to 8. And that means this answer actually should be what now? 8, because they both go to the same place. So this is a stronger condition than these two, right? For these two, you only need it from one side to have something happening. Here you need both sides to be going to the same exact number. All right, we call the left and right hand limits, we call them one-sided limits. Does that make sense? Because you're only coming in from one side. We only look from one direction. The limit without the plus or minus implies we must look from both directions for there to be an answer, right? If not, we write D and E. We're almost there. I might have time to finish this off. Okay. Here's 2. What's the limit from the left? Limit from the right? What's the limit? Does not exist, right? So limit, the left-hand limit at 2 is 8, right-hand limit at 2 is 4, but the limit doesn't exist because the left and right are not equal. So I have it up here, it's written here. I think there's one more. Oh, that one, yeah, let's just skip that one. Let's go to this one. No, I think we're good. All right. So far, everything I've done, are there any math majors in here or no? There's usually not. Okay. Let me just say this. When we talk about this idea of near or close, it's arbitrary, right? It's subjective. We already said like SeaWorld, the sun. Pure mathematicians, that doesn't fly, okay? Nearness doesn't work. You have to have something more precise than that. And there is a precise definition of the limit, a very precise definition of the limit. And some textbooks, most textbooks do have it in there. I don't cover it, and you'll be fine without it, all right? But I'm going to put it on the board, and you'll see why I don't talk about it, all right? Here's the precise definition of the limit that gets around, that we don't have to worry about this nearness thing anymore. We say, you don't have to write this down. We say the limit as x approaches a of f of x equals some number L if for every epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. That's the precise definition of the limit of a function being equal to a number. We aren't going to study it, right? Reason why we don't study this is because there's a ton of stuff you have to know to be able to get into this. Like, you have to know what universal quantifiers are. That's what this is. This upside down A means for every. For every positive number, there exists some other positive number such that if the absolute value of the difference of these two things is less than delta, then the absolute value of these two. How do you prove something like this? How do you do proofs? Do you understand logic? Anyone know how to do proofs? Has anyone ever seen a logic table? Probably not, right? So there's no way we can do this because there's too much foundational stuff you need to get into what's called a delta epsilon proof for the limit. All right? So I just have to put that out there because if it were me, I wouldn't be happy with this idea of near and just like waving my hands at it and being like, okay, near is near. Whatever near is near, right? I'm just telling you there's a way around it. I mean, not a way around it. There's a way to address it. It's just we're just going to have to live with the idea of near being arbitrary in this class, unless you want to get precise. So that's why I asked if you were a math major, because if you're a math major, then you are going to have to deal with that at some point in time. Not yet, but later. Okay, yes? Is that all right? I don't want to get into that more. Last thing, we have 10 minutes, right? 12 minutes? Everything I've done so far, I've given you a picture, right? And I've asked you to figure out left and right and all this stuff. Now, this is different, and this problem is a type that you'll see on a test. I'm going to give you all the conditions, and I want you to draw me the graph that does that. So, sketch an example of a function with the following properties. So think about next class, right? If I were to give a quiz, I may not, probably not, who knows, I might, who knows, right? This is a good example of a quiz problem. Sketch an example of a function with the following properties. And so what I'm doing is I've given you a list here of 8 properties that when you draw this graph, it must satisfy all of these properties. Now I will say to you right now, everybody's picture is going to be a little bit different. Okay, everyone's going to have little differences in the way they do their picture, but we should all have these 8 characteristics in our picture. All right, so let's start going through this. I'll show you how to run through this. Look at the first condition, number 1. The limit as x approaches -2 of the function needs to be 3. Can somebody verbally kind of explain what that means? Who wants to? Approaching from the left. What number are we approaching? We're approaching -2. From which side? Both sides. So I'm trying to trick you here by putting it -2. I'm trying to make you think from the left. No, the negative has to be in the top right corner of that number for it to be from the left. So because there's no negative right there, it's actually from both sides. Do you all see that? So we're supposed to approach -2, from both sides, and it approaches 3. Now I'm just going to start to draw this. I'm just kind of laid out. So here's -2 on the x-axis, right? The idea here is that when I draw this, from both sides, I should be headed where? To 3. Let me draw a y-axis in here. Let's put 3 right here. Okay? So as I come in from both sides, I need to be headed towards 3. Yeah? Let me see if I can do this. Tell me if you agree with this. I'm put an open circle here. I'm just going to put like a little tail off the side here. I'm not quite sure what my function's doing. I'm just kind of making this up as I go. Do you see that from this picture that property 1 is satisfied? That at -2, as I come in from the left and from the right, I'm headed to 3. Do y'all see that? Why did I not put a solid dot? Why didn't I fill it in? Because it's a limit. And the limit's not talking about what happens at -2, right? Only what happens near -2, right? So I have a lot more picture to fill in here. That's just me kind of like putting the idea of 1 down on paper. Who has a question? No? How about property 2? F of -2 is 0. That's college algebra, isn't it? When I plug -2 in, it should spit out 0. That means at -2, I have that. Do you see why it's important I didn't fill that dot in? Because if I had, this would fail to be a function, wouldn't it? So this is property, I'm just going to highlight these here in red. This is property 1 right there. This is property 2 right there. All right, property 3. I'm approaching what number? 1. Let me put that on here. 1 is right here somewhere. I'm approaching 1 from the left, and the function should be headed towards -1. So let me put -1 down here. So as I approach 1 from the left, my function should head to -1, right? So I'm going to do this. Open circle with a little tail coming out that way. Maybe I'm going to should have put it all black. There we go. I could have made this little tail go up or down. It doesn't matter which way it came in. It's just, it needs to be approaching -1. That's why everyone's going to have little differences in their pictures. Do you all agree that that satisfies the third property? Okay? No questions? Come on. It's your education. Fourth property. Approaching 1 from the right. This time I need to be headed up to 2. So when I approach 1, but from this side, I need to be headed up to 2, which I'll do an open circle and a little Open circle up there and a little tail out the right-hand side. Like that, yeah? That is our fourth property. Okay, fifth one. Oh, f of 1 is 2. They're actually giving me the value of the function at 1. It's 2. So I can fill that hole in, can't I? This property right here says at 1, I need to be 2, so I can fill that in. Right? That's our fifth one right there. By the way, you don't need to label these when you do it yourself. I'm just doing this to help you see where things are happening. All right, limit as we approach 4 from the left has to be infinity. The limit as we approach 4, here's 4. We're coming in from the left and we need to head up to infinity, don't we? So since I'm headed to infinity, what I'm going to do is I'm going to draw in here a dotted line like that, just to help me so that it looks like an asymptote like this. I should have done that in black. So like this. That is our sixth one. Seventh is that as we approach 4 from the right, we're headed towards what? 0. Okay, weird. This is weird. As we approach 4 from this side, we need to be headed towards 0, don't we? 0 on the y-axis. So I'm going to put an open circle, and I come into that, right? Doesn't matter which way I come in. I'm going to come in from the bottom. There we go. You could have come in like this. You could have come straight in, doesn't matter. And then f of 4 is undefined, right? Which means at 4, don't put any dots. By the way, if I would have changed this, what if I would have changed this and I would have said f of 4 equals 1? All that would mean is that I would put a dot here, like that. That's all it would mean. And don't be like, but wait a minute, you had a vertical asymptote. This is not a rational function from college algebra. So you can't, it doesn't have the same properties. So this would be okay to draw. But that's not what we had, so I'm going to leave it out. I have what, 30 seconds? No, I still have time. Okay, that's my picture, yes? Now that is not a function because it looks like a bunch of crazy stuff, little scribbles everywhere, right? So what I'm going to do is I'm going to finish my drawing by connecting all my pieces together to make it look like a nice function. So let me start with this right here. Remember how we said this went out to the left? I'm just going to make it do something. It's up to me. I have complete control now because I've satisfied the 8 conditions. So I can make it do anything I want. And what I'm going to make it do is this. I don't know, I just wanted to. Just look cool to do that, all right? And then, let's see. Out the right, it needs to come over here. But wait a minute. See this down here? See how I have to see this? So I'm just going to go that. And then here, come out the right, but then I've got to go up like that, so I'm going to make it go like this. And then over here, I can make it do anything I want. I'm going to make it go down and back up. There we go. There's my function. That function satisfies all these conditions, right? When you're done drawing your function, just make sure it passes the vertical line test. Make sure you never have it hit more than once. What I'll see students do is, remember how we had these two little tails? They'll make this go like this, and then over here they'll make this like go down like that. And that's not a function. You have vertical line test gets violated there, right? Okay. We finished with a minute to spare. So your homework according to our schedule, what I like to do is at the end of class, if I have time, I like to just double check the assignment and I'll either add or subtract problems from here. Let me just make sure there's nothing I want you to skip or additional problems to do. Did everybody sign in? Wow, everybody's here. Everybody is here. This probably won't happen again. So let's enjoy this. All right, so 4, 5, 6. Okay. 6 is going to be an issue. I have a feeling. 7, 8, 9 is good. 13. Okay, we're going to omit number 13. Number 15 and number 17. Well, and number 19. All those three right there, use Desmos. In other words, don't follow the directions. They're asking you for limits on these. 15, 17, 19, they give you functions and they say, hey, what's the limit as you approach something? Instead, go to Desmos, type in the function, and just look at the graph and see if you can figure it out visually, all right? And then, let's see, I want you to do number 10? I took one problem out, right? I took out 13, so in the place of 13, do problem 10. So 7, 8, 9, 10. The expectation would be is that the next time we meet, you will have attempted all those problems, and if you had any issues with them, you either would have referenced my videos, gone to the tutoring lab, or come to see me in my office. All right, everyone, have a great rest of your day. We'll see you on what? Thursday. All right, let me mute, because I'm still on camera. Hold on. Turn this off. Come on through. How's it going? Good? Yeah, come on through. I'm turning off the camera here.